Hello and welcome back to another video of this series here where we draw mechanical design technical drawings. And in the last video I have drawn this O shape arrangement, and I have gotten some comments which pointed out that there are some minor mistakes in this drawing. Well, actually major mistakes, but they're quite small if you look at the diagram. So let's get started on fixing those, and then we'll move on to an X bearing arrangement. So first of all, as you can kind of imagine this drawing here, if you try to assemble this drawing, how would you assemble it? Think about it. You have got a shaft here with a shoulder here and a shoulder here. How are you going to put the bearing onto the shaft? So for example, if you had a straight shaft, right? If you have a straight shaft with nothing on it, it is very easy to put a bearing right onto it, right? Another bearing or a gear or anything. You can put a spacer, a gear, a bearing, a circlip, anything into it with no problem. But once there is a shoulder, that shoulder is going to be blocking the bearing from going in. So how are you going to put this bearing through here or anywhere? Is impossible. So this part that I just drew here in the previous video is impossible to manufacture, or like assemble, right? The shaft is easy to assemble, easy to manufacture. You can just CNC it, but the bearing itself is difficult, well, impossible actually, to assemble into this shaft here, which is why we're gonna first fix this drawing. So how would we realistically do something like this, like achieve an O bearing arrangement? Well, one way to do it is to use circlips. So instead of using these shoulders here, we can instead use circlips, right? We can use the circlip here and the circlip here, etc., so that our technical drawing, our assembly is possible to assemble. So let's just get started on that. Right, so I'm going to just copy this right on here real quick. I'm just gonna draw it really quickly. Bearing arrangement, so it's gonna be yeah, there you go, bearing arrangement. And now let's get started with the actual drawing. So first of all, let's try doing the sketch first. The sketch is gonna look like this. So first of all, our center line, of course, and then we're gonna have our shaft here, and then we want to put our bearings in, two bearings in like that. So we're gonna imagine a straight smooth shaft with nothing on it. We're gonna put bearings in from one side, either this side or this side, right? But we do need to keep them in place. Remember, let's look at this drawing here. We have a shoulder right here on this side and a shoulder right here on this side. Let's just look at the shaft first, right? Because we are gonna have some shoulders on the housing. Let's care about the housing a bit later on. First, let's look at the shaft here. We need a shoulder right here and right here, and right here and right here, right? So how are we gonna achieve that? How are we gonna achieve those shoulders? Well, one way to do it is by using circlips. So well, actually, we don't need to use circlips for both sides. We can just have a normal shoulder from the shaft from this side, because imagine if this is a shoulder, we can still insert our bearings from this end. Even though we can't insert it from this end, this is like blocking us, right? We can't insert a bearing from this end, we can still insert a bearing from this end. Remember, this thing is just a cross section split from the middle. We're looking at the middle view here, right? We can just put one from top and bottom. That's not how it works. We can't just, you know, split the bearing and then do it like that. Now we can't. We have a shaft here with a shoulder here. We can't put it from this side, but we can indeed put the bearing from this side. So what we do need is a shaft that looks something like this, if that makes sense. Right, so if we have a shaft, I mean, this is a bad drawing because it's just a sketch. If we have a shaft that looks like that, then we can, of course, we can't put anything from this side, but we can insert our bearing, one bearing on this side, and another bearing on this side. Right, same, like from the same side. So we can put one bearing in, and then it will stop by the shoulder. So we have our, let me just find something. There's nothing to show you as an example. We have our shaft here, and imagine that this is our bearing. So this bearing cannot be inserted from here. It'll be stuck here, but it can be inserted from this side until it hits here and stop here. It will get stuck here, right? It will just stop here, and then we can insert a second bearing. So I don't have anything to show. Maybe this. Oops. Imagine a second bearing coming here. The second bearing can sit here, and while it sits there, we can insert a circlip onto here so that it is secured here too. I don't know if that makes sense to you. If it doesn't, don't worry, I'll explain it again with the technical drawing. So just to wrap it up, we're gonna have a center line. Draw the center line first, and then our shaft is gonna look like this, something like this, right? We're gonna put our bearing in from this side. Our first bearing is gonna go here, and then we're gonna put another bearing in from this side, same end, another bearing here, and then we're gonna have a circlip right here. I'll show you how to draw circlips. Circlips are drawn like, I'll show you in the technical drawing, and then we're gonna put it in the housing, which will look something like a shoulder here, like that. Everything will be clearer when I draw the technical drawing, right? So yeah, let's get started with the technical drawing. Let's do our sketch first. Your center line, let's do our center line first. There we go. Again, I'm drawing with a pencil first. Right, and then let's draw the thing. Then I'm gonna draw all the way to the end. So I don't know. I'll leave about this much for the shaft. Then we're gonna have a little bearing right here with the circlip. And then we have our bearing's gonna sit here. I'm just kind of making plans in my head to make it look great, right? Then we can have our second bearing here. Again, if you want to draw, you can draw along. The first diagram is kind of wrong, so disregard it. Then we're gonna have our first shoulder down here. Let's just complete this drawing. Then we can draw the same thing on the opposite side. Yeah. There we go. So this is what our shape is gonna look like. Right, let's insert our bearings in. So actually, yeah, let's insert our bearings in, and I'll explain. We don't actually insert our bearings in first. If we're doing it in real life, if we're assembling it in real life, I mean on the technical drawing, of course you can draw it however you want, like you can draw it in any order you want. It's a drawing, the end result is going to be the same. Doesn't matter, it's not Chinese, all right? It's not Japanese kanji where the stroke order matters. The order of your drawing doesn't matter. But in real life, if you're assembling this, I'll show you that you cannot insert the bearings first, because it's impossible to do it. It is impossible to insert the bearing first. It will be blocked by the housing. The housing has this little notch here, which prevents the bearing from going in. But I'll explain it after drawing this. Think that's it. Yeah. Right, and then let's put our circlip in now that our bearings are complete. So our circlip's gonna sit here, and to draw a circlip, it is quite simple. You draw like two little thin rectangles here, and shade the top one black, while the bottom one is like not shade, like fully color it in, like fill it in, fully black like that. This is how you draw a circlip. This is a circlip. Now, as you can see, we have a contact point here, 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 and here. So we have a, so all we need to do is put the housing in so that the connect points contact there. Amazing. So let's go ahead and do that real quick. We are gonna need contact points right here. Yep, all looking all fine. Just making sure I'm not making any mistakes. Yeah. And there we go, just the housing there. Then I'll copy the same thing down here, reflect it. There we go. Now let's shade in our technical drawings. I'm sorry, bearings. What am I saying? Make sure that they are correctly drawn, these little lines here. You know, just draw one correctly, and if you reflect it, everything else will be correct. Now let's shape them in. That should be correct. That. Yep, an O arrangement. You can see the O in there. I explained it in the last video. Yeah. Right now let's shade the housing. There we go. And there it is, our pencil sketch is complete. So now let's talk about actually assembling this. What you have to do is first put your bearing in. So without the shape, like imagine the housing first. Imagine the housing looks like this. You've got a housing here, and you want to put a shaft in here. You want to put the shaft through here like that. You see that? Got a shaft here. Actually, it should be like this. Sorry. Yeah, there we go. You have your shaft here, and you want to put it in like that. All good. Now the problem is, once you put a bearing on the shaft, or imagine this, even without the shaft, if you have a bearing, that bearing cannot pass through this notch here. Imagine this bearing, or actually this bearing. If you're inserting from the left side here, if you're having your shaft go in from here with your bearing attached like this, so your bearing is attached like this, you have your notch here. So imagine this little notch is the shoulder here, right? This shoulder here is on the shaft. The shaft has a shoulder built onto it. You have your bearing put into your shaft, like so, like that, right? It stops there because it's stuck by the shoulder. If you try to insert it, it will go in until here, where your bearing will get stuck on this little notch here. So what you have to do is, you have to first insert your bearing into the housing like so. So you're gonna have your bearing like that from this side without a shaft, because if you have the shaft, you can't really put anything in there. So you take your bearing, you put it in here, insert it into the housing first. Once it is in the housing, you take your shaft and you insert your shaft from the right side. So now imagine that now you have this thing, and then you insert your shaft from the right side going into the bearing. So you're gonna have your housing, and then inside your housing you're gonna have a bearing in there like that. So you're gonna have a round hole, and within the hole there is gonna be a bearing with another hole in there. Then you insert your shaft into the bearings hole, and it will fit in nicely. And then once that is there, you can put your bearing, second bearing from the left side, put it in, and then secure it with circlips by putting a circlip in here, so that the bearing doesn't just go out, slip out, because without a shoulder it can slip out, and it will slip out, and the circlip makes sure that it is tight and that it won't slip out. Right, so I hope that makes sense. So just to recap, this is an O arrangement drawing with a few minor changes, especially with the circlip here. And to assemble it, we first get the housing, put the bearing in the housing, get the shaft, put the shaft from the bearing from the right side into the bearing, and once it comes out on the other side, we take the second bearing, put it in, put the circlip in. All right, now I am missing one more minor detail here, and that has something to do with the shaft here. So imagine you have a shaft. So let's forget about this for a second. Let's go back to a smooth, plain, nothing shaft. So if you have a shaft, it is a rectangle. I mean, of course, a shaft is a cylinder, right? It looks like a pencil. Okay, this is a shaft, kind of. If you attach it to something and make it spin, it's a shaft. I mean, technically, this is being a shaft right now, and my fingers are bearings. Yeah, my fingers are rubbing against, like, you get the idea. So if you look at it from the side, it's a rectangle with very sharp right angles, right? And if you try to put a bearing in there, so imagine a bearing here. If you look at it from the side, it looks something like this. If you try to put this bearing in here, I don't know if you can see clearly, but if you try to put it in here, you have to put it in perfectly perpendicular to this shaft here. So you have your shaft here. This is better shown with the ruler because it's rectangular. And you have your bearing here. This bearing needs to be perfectly perpendicular, like 100%, like 90.00 degree perpendicular, to be able to fit in and go through. If it is rotated by even a little, it won't be able to fit in, because like, look at this here. If you have your shaft and you have your bearing kind of very little bit like rotated, the space is smaller now. If you rotate this by a little bit, this little space is like smaller now, right? Compared to if you have this, see, you can see how this is larger than this. So we have but remember, the bearing is the hole, right? The hole is smaller now. So now the shaft can't really fit into the bearing inside the hole, or anything actually, like gear. It could be a gear, it could be a spacer, it could be a circlip, anything. It could be a washer, it could be um, whatever. So that is a problem in real life too. So if you have a cylindrical shaft and you want to put a bearing into it, you have to align it perfectly to like put it in, or else if you're even off by a little bit, like you won't be able to put it in. It will hit with the side. It won't even go in a hole in the first place. It won't be able to go into the hole, so into the opening. So a way to solve this is by using chamfers. I think that's the way. Actually, let me just look it up in case I'm wrong. Chamfers. Yep, chamfer. A chamfer is basically instead of a straight up, wait, let me just draw a cylinder first. So this is the shaft. Instead of a straight shaft, we cut away this little diagonal part here. So these corners are cut off. So instead of a shaft being like this, it looks something like this. That makes sense. So we're gonna have a little smaller, it's gonna chamfer in like that, then flat out again. So that even if your bearing or your gear or your spacer, even if that is tilted, then it can still go in into the, sorry, the shaft can still go in into the opening, right? I mean, the bearing doesn't go into the shaft, that doesn't make sense. But the shaft can still go into the bearing, so that if you insert your shaft into the bearing, then the shaft will, it doesn't matter how little degree, how much degree it tilts. I mean, it can't tilt like that, like 90 degrees, of course not. But even if you have some human error, if you have some like very tiny errors, it can still go in and fit. And it is also useful for engineers or mechanics to feel the chamfer and like so that they can align it, right? The point of a chamfer is basically to align the bearing to become 90 degree, perfectly 90 degrees with the shaft, or vice versa. It is to align the shaft perfectly 90 degree with the bearing, so that they are perfectly aligned, even if you initially started with a misaligned, like by a few degrees, right? So let's talk about chamfers for a second. There are actually three types of these. There is the chamfer, there are bevels, and there are fillets. So a chamfer is, like I said here, a chamfer is you have got a you've got this thing here. This is a chamfer. You've got a, most of the time, 45 degrees. Actually, this is getting a bit messy. Let me just open a new page. Right. So a chamfer is where you have a shaft, and if things are difficult to go in the shaft, I mean, it is going to be difficult to go in shaft. So what you do is you cut this off. You cut this off to make something like this. Right, that is a chamfer. So that if you put stuff in there, like me, sorry, if you put this into stuff, it will auto align to be 90 degrees. Now, this is called a chamfer. Now, a fillet is basically like a chamfer but rounded. So let me draw three diagrams here. So first we have a chamfer. This is a chamfer. It is like straight edges. These are sharp corners. A fillet is basically the same thing but rounded. So instead of a sharp corner, it is rounded like this. So this is a chamfer. Sorry, spelled it wrong. This is a fillet. Right. And then finally we have a bevel. A bevel is literally like a chamfer, but it goes all the way through the material. So this, in this case, this is gonna be a bevel. And if it doesn't really show on camera, I'm gonna draw it again with a pen. So we have a chamfer. Then we have a fillet. There we go. Then we have a bevel. There we go. Those are the three different types. But here we're only gonna use chamfers for now on, forever. Not forever, but like for now on in our material design, in technical drawings that we're gonna do in this series. We're only going to use chamfers. And now there are two types of chamfers, of course. There's the 45 degrees type. There's the 20 degrees type. Right, 45 degrees chamfers look like 45 degrees, like these. These are 45 degree chamfers, right? 20 degrees look like, well, 20 degrees, so they are a bit narrower. They're about a 3:1 ratio ish, 2.7 actually to be precise, but like let's just pretend like 3:1 ratio. I mean the gradient, I mean like that, yeah. So 1 square down and 3 square right, or 1 square down and 3 square left, right? So this is like a 1:1, 1 square down, 1 square right. Let me just draw it in a pen neatly. So there are two types of chamfers. There is the 45 degree chamfer, which look like this. And then the 20 degree chamfers, which looks something like this. Right. So these are two different types of chamfers. One we use, which depends on your use cases, which I am not very sure of, but from what I know, what I understand, is that 45 degree chamfers are used on shafts when you are trying to fit things onto the shaft. For example, bearings, gears, spacers, circlips, washers, etc. And 20 degree chamfers are when you're trying to fit the shaft into pistons, so into a cylinder, I mean. So like for example, they're used in pistons, and they're usually used for when you're using with seals. They're used as like a sealant type, like for liquids to not flow out. I'm not quite sure specifically on the 20 degree chamfer, but I am sure that like we're gonna be using mostly 99% of the time 45 degree chamfers on our technical drawings in this YouTube video series. So recap, we have three different types of these little the cutouts, I guess. I don't know what you call them. So we have a chamfer, which is a straight cut that has sharp angles. We have a fillet, which is a rounded cut, and then we have a bevel, which goes through all the way through. And then for a chamfer, there are two types. There's the 45 degrees, 20 degrees. 45 degrees is usually used when you have a shaft and you're trying to put things onto the shaft. The shaft doesn't move, the shaft is something stationary. You hold the shaft, or the shaft is somewhere that is secured in place, fixed in position, and then you put the things that you want to put on the shaft onto the shaft. So for example, you put bearings onto the shaft, you put the gears onto the shaft, you're trying to fit holes onto the shaft, right? Openings onto the shaft. 20 degrees are usually used when you want to put the shaft into a hole. So if you have a cylinder or if you have a piston, then you want to put the shaft into that hole, then you use a 20 degree chamfer. So you are now holding the shaft instead of holding the bearings or the gears. You're now holding the shaft. You're trying to jam the shaft into something, right? You have like, so Okay, the 45-degree one, you have the shaft, you're trying to put things into the shaft like that. 20-degree, you have an opening, you hold your shaft and trying to jam it into something. And usually that is used for sealing liquid, and that is the only thing I can think of. But yeah, so we're only gonna use 45 degrees in this series. May make the 20 degree one may pop up, but yeah, anyways, so let's put shaft first on here. So we have our shaft here. Our shaft, it is difficult to put bearings from this side into here if it is a right angle. So to put shaft first in, it is easy. We just draw a little this for to make sure it's like about 45. I mean, it doesn't need to be exact, but we are using grit paper, so like it's very easy to be exact. There we go. This is gonna be our 45-degree chamfer, and we have it. There we have it. So because of our chamfer, we can now put our first bearing in, second bearing in, no problem, even our circle clip in. Amazing. So let's try drawing this with a pen. There we go. Let's draw our chamfer. The thing, yeah. So now that we have our chamfer, center line, chamfer line, center line, we can draw this. Then let me draw it all the way straight through till about here. Nice. Same thing on this side. Amazing. Then we're gonna have a shoulder. Awesome. And this will be our shaft. You can see how beautiful it is. Now we can draw our bearings in. So our first bearing that we're gonna insert into the housing first, and then we insert the, well, I mean, technically speaking, you can insert the bearing onto the shaft first, and with the bearing attached to the shaft, along with it, we can insert the whole thing from the right side in like that. But it is actually a little bit more difficult if you're doing it in real life. Like when you're assembling a gearbox in real life, it is harder to do that. It is easier to just get the bearing into the housing first and then put the shaft in. But technically speaking, you can do it, or realistically too, you can do it. You can just put the bearing onto the shaft and then put the shaft into the housing from the right side. But it's a lot more, you gotta move through the very tight housing. It's a pain in the ass, that's what it is. There you have it. And now our other bearing. Just copy this. Same on this side. Right, now the housing. Again, I'm just gonna copy the top one. Not really gonna think about it that much. There we go. Now let's shade. Oh, and the circle clip, of course. There we go. And let's shade it. And then the housing. And there we go. This is now the accurate bearing diagram. Again, just to verify, forces go in this line of action, so they go in this O arrangement. Right. So now we have cleared up our O arrangement bearing, let's move on to our X arrangement bearing, which I had actually drawn before recording this off camera. However, when I was drawing this, I did not know about the mistakes that I made. Here I did not know about chamfering, I did not know about the bearings, like the assembly not being able to assemble in real life. So all I did, like the drawings I made, were still wrong. So what we can do here is we can kind of redraw it again. First of all, obviously there is supposed to be little chamfers here, you know. And second of all, this is also impossible to assemble in real life. Like, think about it, imagine it. How are you going to get the bearings into the housing in the first place, right? So you've got the housing here. How do you put that bearing into the housing? You can't. You physically cannot. It's like utterly impossible to put the bearing into the housing in this arrangement here. You can't assemble it. Putting it into the shaft is very easy enough. You can just put a chamfer here, and through the chamfer you put one here, right? You have a shaft here, done. But what about the housing? How do you put the shaft inside the housing? You can't. How do you put the bearing inside the housing without the shaft? You can't. So I'm going to show you how to draw it properly. So this is the principal sketch that is correct. These are a little bit wrong, but by theory, if you're not assembling it in real life, by theory, if you can just create this out of nowhere, out of magic, then this is correct. This is an X arrangement bearing, because if you look at the line of actions of the forces, it goes like this and goes like this, right? So this goes like that, this goes like that, this goes like that, and this goes like. If you connect them all together, it is an X arrangement bearing. Same here. I mean, yeah, you get the idea. It's here to here, here to here. You have your contact points here, contact points here, contact points, contact points. It's an X arrangement. So let's try drawing this properly. And then in the next video we'll move on to a new topic, because I was like kind of planning for this video to be about a new design but because of the mistakes, I'll fix the mistakes first, and then we'll do the new design in another video, hopefully next week, because I do weekly videos. My last video was last week, but uh, because of like mobile to like YouTube doesn't like videos recorded on mobile, so I gotta re-encode them, and they haven't been uploaded yet. They're still processing. But anyways, yeah, the first video is gonna be late. I mean, it was late. You're watching this after the first video. The first video was late because of that. Sorry about that. The second video, this one right here, it will be uploaded like a few days after the first video, I think. I mean, as of recording right now, the first video is being uploaded. It's just not on YouTube yet. So, but if you're watching this right now, then it is already on YouTube a few days ago. You know what I mean? Yeah. But yeah, the next video will be out probably next week. Like, hopefully next week. So our X arrangement drawing, they're gonna do that. So let me just make sure. Yep. So as you can see here in the next arrangement, perfect. So let's look at what our drawing might look like. So the shape is simple. The shape is a very simple thing to draw. So let's draw our center line first. We can draw our shape the same way that we drew in our in my drawing that I made off camera, like that. I think you can see it a bit clearly. If you can't see it clearly because of the shadows and the lighting, and because I'm using pencil on camera, it doesn't really show well. I'll draw it in the final technical drawing. But what I'm planning to do is use the normal shaft. We're not going to modify it. Put the bearings on the shaft using the chamfers here, so that the chamfers are basically like guidelines for the bearing to rearrange. We're gonna put the bearing in from the chamfer, so one from the left side, one from the right side. So we're gonna have this. We're gonna have a thing in the middle, the shoulder in the middle. Put one here, put one here. They're gonna stop that shoulder. Now the problem comes from inserting that into a housing. How do we insert something like that into a housing that looks like this? We can't. So what we can do is we can kind of modify the housing to remove this part. So the housing actually looks like this. This is what the housing is going to look like. And then we can insert our shaft into here. So our shaft is going to sit in here. I mean, obviously these are not going to be touching because I drew the housing too close together. But we're going to have our two bearings here. So our shaft, then our second bearing here. Again, this is a very stupid sketch. So we're gonna, again, just to kind of recap, we're gonna have a housing that looks like this, right? And then we're gonna insert our shaft from this side, like that, including the bearings, right? The bearings are gonna go in the shaft first. Shaft like this here with the little shoulder in the middle, bearing from left and right, and then insert the shaft into this housing from the left side. So now we have this. How do we close this off? Simple, we use a lid. So every housing kind of have a lid, of course. So we use a lid to close this off using a lid. So basically the lid was looking like this. So after this, we're gonna put the lid in. Like this. We'll go in like that. Does it make sense? And then of course we'll secure the lid by screwing it in or using seal, or sorry, not using seal, scissors for making sure that things don't go out, fluids don't go out. um usually like grease, so like grease don't go out. But we're gonna use screws to make sure that there is enough force pushing it, there is enough, like, how do I say, like enough reaction force, normal force, like squeezing it, squeezing the bearing in, so that there is this little X arrangement happening. Yeah, like that, X arrangement. So we're gonna have a contact point here and here. Those are the most important ones. These are already kind of contacting here, so we don't really need to worry about them that much. All we need to do is we gotta worry about how are we going to push this in, and to do that we can use screws, because screws have like a really torque to axial force, um yeah, like converting thing, is very good at it. I'm bad at explaining it. I myself don't understand that much, but my point is, if you put screws in here, then it will tighten it. Yeah. So I'll show you how to draw screws. They're drawn by using dash line, but first let's draw our technical drawing in pencil first. Okay, and then let's draw our shaft, which is the easy part, because it's just one thing. Just check. I think the shaft stays the same. Yeah, the shaft stays the same. Just making sure. We're gonna have our bearing here, our shoulder here. Bearing, shoulder. And the bearing, the shoulder can go on for, I don't know, any amount. Good enough. Then the shoulder will end here. And then we're gonna have a second bearing here. There we go, and then let's just close everything up. Now we can draw our bearings in. Right. And then our balls. Right. Oh, and of course, forgot the chamfers. There we go. And now we can draw our little housing this side. We'll fill in the bearings later. Just want to make a visual so that I know where they are pointing. I mean, I already know where they're pointing, but you know. Same on this side. Okay, and then we can put in our screw. So like the lid, I mean, yeah. Let's put it in our lid first. Same on this side. Okay, there we go. So let's show you how to draw the lid. Sorry, how to do a screw. So we're gonna screw the lid in here, right? This is the lid. So how we're gonna screw is we're just gonna draw a dashed line through what we are screwing, so it will look something like this. There you go. That's it. That's to say, screw same on this side. Doesn't need to be that long. There you go. There you have it. Well, so let's shake things in, or bearings in, etc. Then we will be done with our pencil sketch. Well, I mean, I shouldn't have done that actually, now that I think about it. Should make these in a different direction, because these are different from the housing. This is not part of the housing, this is part of a screw. I mean, a lid. This is a lid. This is why we use a pencil, so that you can erase it later. Okay. And these are like largely spaced, so they're different from this. You know, same here. It'll be much clearer if I draw it on a pen. There you go. And there you have it. This is our finished sketch. Hope you enjoy it. And if you're following along to this point, congrats. And thanks for following along, I guess. Alright, so let's draw our little hand drawing. Check this here, everything seems to be alright. Now, being an engineer is pretty fun. I mean, an engineering student. We're about to become engineers, you know what I mean? Well, not about to. We still have like a lot of years ahead of us. But it is pretty nice from time to time. Some subjects are really interesting, some are really a pain in the ass. Most of the time, the joy comes from like the process and not really the end result. I mean, I'm sure the joy will come in the end result too, but like my point is, like studying is more fun than taking exams, or maybe the other way around for some people. Maybe taking exam is way more fun than studying. For me, it is a bit of both. I like the quiet exam room, and I like the adrenaline thrill of like taking the exam and like having time pressure on you, etc. And I mean, the exam kind of forces you to study too. And my kind of purpose here is to learn engineering then rather than like become an engineer. I mean, I do want to become an engineer. That's like the secondary purpose. I think my primary purpose is to gain more knowledge about, well, things, especially engineering and mathematics. Yeah, which is also why I have a YouTube channel, Liger Science. Liger Science is like kind of the project, a side project that is helping me live through this, to have more, will and like more curiosity and enthusiasm. I made a mistake here, but whatever. And yeah, does that mistake? Yeah, that mistake's kind of hurt, but it's okay. Don't need to worry about it. Anyways, like I was saying, Liger Science kind of fuels me with more curiosity, and like educating people on the internet. Just have this little warmth in my heart. The feeling of like sharing knowledge and what humanity has achieved to other people. It feels great. It feels great to be like an educator, because I'm also, in case you're not familiar with me in real life, I am also a high school teacher. I teach math, physics, mostly science. I have also taught in like college, but as a TA, sometimes a substitute teachers, in case the lecturer doesn't come or the professor is missing. You can call me a lecturer. Yeah. Anyways, yeah. So I love sharing my knowledge and education to other people, and when they understand things that I have explained to them, it makes me feel nice. Okay. This part of the housing is pretty bad, but whatever. There we go. Let's do the shading. The mistake doesn't really feel that obvious anymore. Right, and then let's put our screw in from this end. Same on this side. There you have it. And that, my audience, is how you draw a X arrangement bearing. Well, thank you very much for watching. I will put a link in the description to all the resources for drawing technical drawings, so that you can also look ahead when I haven't uploaded my video. But otherwise, yeah, thanks for. I don't think I can actually publish all of the material because of copyright, but I can show you what I can show you, and I will show you what I can show you, everything I can show you. So great, thanks for watching. I mean, just to summarize what I just did, we have a housing that looks like this. We have a shaft that looks like this. We have chamfers on so that we can put the bearings in. We put the bearings in into the shaft. We put the shaft into the housing, and then we put the lid on like that. We drill a little hole, and we put screw in, and we screw it in. This is our X arrangement bearing because the contact points are here. Line of action of force goes like that. Contact point here. Line of action of force goes like that. You know, like that. So they all make an X arrangement. This is why we call it an X arrangement bearing. I'll see you in the next video where we talk about a new system arrangement, whatever. See ya.